The next method is difference of two squares, a square minus b square. Now before we begin, do you know what is a square minus b square? The identity a square minus b square is a plus b into a minus b, difference of two squares. So your question will be in this form and you have to factorize it and bring the answer in this form, and simply use this identity. A square minus b square is a plus b into a minus b. That's it. Right? Let's do some questions based on this. X square minus 25. So x square minus 5 square, I can write it as difference of two squares. So x plus 5, x minus 5. That's it. Next question. Nine bracket x minus y the whole square minus x plus 2y the whole square. Now the first term is this and this is the second term. Second term is in perfect square form, but the first term has 9 also, but 9 is also a perfect square. So 3 bracket x minus y the whole square minus x plus 2y the whole square. So this will become 3 bracket x minus y plus x plus 2y and 3 bracket x minus y minus x plus 2y. I will simplify this further. This will become 3x minus 3y plus x plus 2y, and in the second bracket it will become 3x minus 3y minus x minus 2y. This minus sign, when the bracket opens, it multiplies with both the terms. So 3x plus x will be 4x, minus 3y plus 2y will be minus y. 3x minus x will be 2x, minus 3y minus 2y will be minus 5y. So 4x minus y and 2x minus 5y. These are the final factors. Let's take one more example. 48x cube minus 27x. Now in the first glance you think that there is no perfect square over here, but I want you to look very very closely. Can we take out something common from both the terms? What is common in both the terms? See, in 48 and 27, what is the highest common factor of 48 and 27? It is 3. And in x cube and x, what is common? X is common. So if you take out 3 common and x common, what will be left inside? 16x square. And if you take out x common and 3 common, what will be left inside? 9. So 4x square minus 3 square. So this will become 3x bracket 4x plus 3, 4x minus 3, 4x plus 3, 4x minus 3. So these are the two factors. One more example we'll take. Okay, this will become 4a square the whole square minus b square the whole square. I have to convert them into perfect squares. So raised to 4 can be converted into squares raised to square. Okay, so this will be 4a square plus b square and 4a square minus b square. Now 4a square minus b square is also difference of two perfect squares. So 4a square plus b square, and this will be converted into 2a the whole square minus b the whole square. 2a plus b, 2a minus b. So your final factors are 4a square plus b square, bracket 2a plus b, bracket 2a minus b. So these are some examples of difference of two squares. Now let's take some challenging ones, some difficult ones, right? Next example, a square plus b square minus c square minus 2ab. Now the actual challenge of the chapter starts, because the questions will not be straightforward, and which method to use will increasingly become more and more difficult, right? So see how I'm doing it. Just observe what I'm doing. I'm finding a pattern. A square minus 2ab plus b square minus c square. So what I did is I'm doing some rearrangement. What is a square minus 2ab plus b square? If you know the identities well, this is a minus b the whole square minus c square. So again, difference of two squares, so it will become a minus b plus c and a minus b minus c. So this is your factorization. Let's take one more example like this. 16x square minus y square plus 4yz minus 4z square. Now there are four terms here. Now an idea might come to your mind that let's do grouping and taking out common. Let's take these two together and these two together. Now if you take these two together, there is nothing common. If you take these two together, the 4z is common and y minus z will be left inside. But then you cannot proceed further, right? So grouping and taking out common does not work with first and second terms and third and fourth term. So what if you take first and fourth term and second and third term together? 16x square minus 4z square. Only 4 is common. Inside 4x square minus z square will be left, and you cannot do much with that. What about y square plus 4yz? Only y is common and y minus 4z will be left inside. Again, you can't do much thing with that. So try to find a pattern which we did in the earlier question. So what is the pattern which we used here? Here what we did was we found out square of a binomial, that is perfect square, in the form of a trinomial. So 16x square minus, if we take out minus common inside, what will be left? Y square minus 4yz plus 4z square. Now you see these three terms, that's a perfect square of a binomial. But how we know that? See, 16x square minus y square minus 2 into y into 2z plus 2z the whole square. See, a square minus 2ab plus b square. 4z square can be written as 2z the whole square. 2z is your b, a is your y, and 4yz will become 2 into y into 2z, that is 4yz. So this will be 16x square minus y minus 2z the whole square. Okay, this can be further factorized into 4x the whole square minus y minus 2z the whole square. So 4x the whole square is 16x square. I can write it as 4x. This is a square minus b square, 4x plus y minus 2z and 4x minus bracket y minus 2z. A plus b, a plus b, a minus b. This is your a, this is your b. Okay, you can simplify it further. 4x plus y minus 2z and 4x minus y plus 2z. How did I do this? I just opened the bracket. Right, so that's your again difference of two square method. Let's do more examples on this. One minus x square, 1 minus y square plus 4xy. Again, if you see, look at this question, it does not look like from any of the method you cannot group and take out common. There is no trinomial, splitting the middle term is not possible. So what to do? So 1 bracket 1 minus y square minus x square bracket 1 minus y square plus 4xy. So what did I do? I just simplified this by multiplying these two binomials. Just open everything up. 1 into 1 is 1. 1 into minus y square minus x square into 1 is minus x square. Minus x square into minus y square is plus x square y square plus 4xy. Okay, let's go ahead. What pattern do we see here? Now we have got 1 2 3 4 5 terms over here. What is the pattern which we see here? I see something interesting. Just pay attention over here. Can I rewrite everything over here? I'll just take some space. Can I rewrite everything over here as okay, so I will write as x square y square plus 2xy plus 1. Okay, x square y square I wrote as it is. This 4xy I split it into 2xy. There is one more 2xy which is going to come, and this 1 I have written here. And minus x square plus 2xy minus y square. I used this minus x square here, this minus y square here, and one more 2xy which was remaining, I used it here. So what do I get here? I just put it in the bracket so that you guys don't get confused. X square y square plus 2xy plus 1 minus, this will be x square minus 2xy. Yes, plus y square, correct. So I took out minus common and I wrote these three terms in the bracket. Why did I do this? Here, if you see closely, this is of the form of a plus b the whole square. How? xy the whole square plus 2 into xy into 1 plus 1 the whole square. Do you see the pattern now? A square plus 2ab plus b square. minus, this is also of the same form, a square minus 2 into a into b plus b square. So these both are perfect square trinomials, that is of the form a plus b the whole square and a minus b the whole square, right? A square plus 2ab plus b square is a plus b the whole square, that is xy plus 1. This is your a, this is your b, and this is whole square, minus this is of the form a square minus 2ab plus b square, so a minus b the whole square. See, I converted the whole jumbled up equation in the form of difference of two squares. Very, very important. A square minus b square is a plus b, and a minus b. Whenever I write minus, the second term will come in the bracket automatically. So xy plus 1 plus x minus y, and xy plus 1 minus x plus y. Right? So these are the two factors. The next example is x raised to 4 plus x square y square plus y raised to 4. Again, if you will observe this question, you will find that it is neither in the form of perfect square trinomial, that is a square plus 2ab plus b square, because if it would have been, then there would have been 2 over here. There is no 2. So it's not of that form. Also, you cannot do splitting the middle term. Taking out common, not possible. There should be 4 terms for grouping. So what can be done? These are the questions which will give you actual challenges while doing factorization. Specifically in this chapter, you will find such questions. Let's try. Please observe the method which I am using very, very carefully, the tricks which I am using, techniques which I am describing over here. Okay. So I don't have 2 over here, but I can definitely put a 2. So x raised to 4 plus 2x square y square plus y raised to 4. Now you will wonder that there was no 2. How did I put 2? I put 2 over here, I agree, but I can also write minus x square y square separately after all the 3 terms. So plus 2x square y square minus x square y square will become plus x square y square. So actually I am not changing anything. I am not changing the question. I am just writing x square y square as 2x square y square minus x square y square. But how is this going to help us? So just see this, x square the whole square plus 2 into x square into y square plus y square the whole square minus x square y square. Do you understand this? I converted the first 3 terms into the form of a square plus 2ab plus b square. Now see how I write it. A plus b the whole square minus xy the whole square. Now it is of the form of difference of 2 squares, a square minus b square, which is a plus b and a minus b. X square plus y square plus xy and x square plus y square minus xy. Let's do one more question similar to this. P square plus q square minus r square the whole square minus 4p square q square. So this can be written as p square plus q square minus r square the whole square minus 2pq the whole square. Why 2pq the whole square? Because I wanted to bring it in the form of a plus b, sorry, a square minus b square, which will give me a plus b, a minus b. So this will become p square plus q square minus r square plus 2pq, p square plus q square minus r square minus 2pq. So this will become p square plus 2pq plus q square minus r square, p square minus 2pq plus q square minus r square. Why did I bring plus 2pq over here and minus 2pq over here? Now you can see the pattern: a square plus 2ab plus b square, a square minus 2ab plus b square. What is a square plus 2ab plus b square? A plus b the whole square minus r square. Okay, here p minus q the whole square minus r square. So a square minus b square is a plus b and a minus b. Here a square minus b square is a. Your a is p minus q plus b, a minus b. So p plus q plus r, p plus q minus r, p minus q plus r, and p minus q minus r. These are the complete 4 factors of our given expression. Okay, so this was method number 4, that was difference of two squares. Many different types of questions we saw in this, and the next method is going to be sum or difference of two cubes, which we are going to do in the next video. See you in the next video.